Hello students, in this session we will do sums from collision. So we will complete all the sums that are related to collision, and then we will do sums from the year 21, 22 and 23. Okay, so those sums will also get completed. Finally we have like one sum that is from the chapter of units and measurements, so that is actually related to dimensional analysis. Okay, so altogether you'll get around like 11 sums that we will complete in this session. Fine, let's jump into the next question, which is like 58. So in this sum they have given you a ball is thrown vertically downwards from a height of 20 meters. Got it? So you're throwing a ball downwards, which means the initial velocity was not zero. You're throwing it downwards. And the height of the particular building is actually 20 meter with an initial velocity v naught. So there is initial velocity to it. It collides the ground, loses 50% of its energy in collision. Got it? So when it hits the ground, it has lost 50% of the total energy with which it has reached the ground surface and rebounds to the same height. So initially I just gave initial velocity to it. Therefore, when it was supposed to reach the earth surface, it had actually extra velocity to it because I gave certain velocity to it. So from my hand, I have inputted some energy into it. So together, there was like some amount of kinetic energy with which it got hit the ground. But after hitting the ground, 50% of that total energy got lost. Only by leftover 50% it was able to rebound to the same original height. Got it? If it was a situation where I just dropped it, it wouldn't have reached the same amount of height because 50% has got lost. As I have given also some energy to it, the leftover energy was good enough to make that ball to rebound to the same original height, right? So that's the idea behind it. The initial velocity v naught is, so they're asking us to get the initial velocity. Let me draw the diagram for the question. You'll get it pretty more clearly. So you're having an earth surface, and then I'm just going to drop a ball from certain height with initial velocity v naught to it. It reaches the ground surface. Okay, so it reaches the ground surface and then the velocity was equal to v. Fine. So with this, it has lost 50% of its energy with remaining 50% of its energy, which means 50% of half mv square. Got it? So it has reached the earth surface, the velocity was equal to v. Initial velocity was like v naught, final velocity was v. With this, it has lost 50%. With leftover 50% energy, it was bouncing back, and then it was able to reach the same amount height h. Got it? So that's the understanding that you need to know. Obviously, 50% of half mv square should be equal to mgh because it was able to reach the same amount of height, right? So it did bounce back and then reach the same amount of height with this 50% of its energy. Fine. So this is the diagram that is needed for this question. So it is pretty obvious I'll have to use the kinematic equation. In this situation, it is clear there wasn't any time parameter that is given in the question. Therefore, I'll have to choose the third kinematic equation, which will be like v square minus u square, which will be equal to 2gh, right? So in this question, v square was the velocity with which it hits the ground minus u square. So the initial velocity was like v naught, that should be actually negative v naught square. Anyway, as I'm squaring it, it will become positive. So v naught square, that should be equal to 2gh, right? For g, it will be negative 10 as it is downwards. Same way, the displacement is also downwards. Therefore, you'll have to plug in one more negative h into it, right? So this notion should be clear. Negative h, or they have given you the question, they have given height in the question itself, which is like negative 20, right? So that should be like negative 20. So you should be clear with the sign conventions that I'm using over here. V square, that was negative, as I squared it, it will become positive minus v naught square. Same thing goes for like v naught square, which should be equal to 2 negative 10 and then negative 5 because the displacement is getting covered in the downward direction, right? So this should be clear. What I am supposed to find over here is v naught. As I have two unknown variable over here, the other equation that I have got is 50% of half mv square should be equal to mgh. So from that, I'll be able to get the v square. If I plug in that v square into this one, I'll end up getting the v naught square, right? Simple sum. Yes, just two more extra steps, you'll get the answer. So the next one will be from this thing. So you will have something like this half, okay, m v square is something that I need to get, right? V square, that will be equal to m, g will be like 10, height is going to be like 20. Okay, so In this stuff, you do not want to worry about the direction because this is just an energy balance over there, right? So half mv square and then 50 percentage of half mv square, right? So you'll have like one more half into it. So 50 percentage, therefore you'll have like one more half into it. So if you do all this one, you'll get it, right? So here m will get cancelled out, and then 1 by 4 it has to get multiplied on the other side. Therefore you will have v square, which will be equal to 4 into 200, right? V square will be equal to 4 into 200, so that will give you like 200 root 2, isn't it? Yeah, anyway, I just need v square, so let me substitute this v square into this, the above equation. So let me substitute this v square into this one. I'll get the answer. So if I do substitute that one, you will have, that one is like 800, which will be equal to 800 minus v naught square, right? Negative of v naught square, that should be equal to, you would have got, yeah, 400, right? So 400, so that will give you v naught square, which will be equal to 800 minus 400, that will give you like 400. What if I take the root for it, you will have v naught, which will be equal to, you will have v naught, which will be equal to 20 meter per second. Got it? The answer here is 20 meter per second, which is like option 4. Fine, you should be clear with this question. The answer is like 20 meter per second. You shouldn't have any doubt on this question. Simple one. Let's move on to the next one. Next question is also simple one. Here you have got, on a frictionless surface, there is a block of mass m moving at a speed b collides elastically with another block of same mass capital M, which is initially at rest. Fine. So initially there were like two masses. There was a block of mass m which was actually moving with the speed v. The other mass was at rest and it collides with that mass. Got it? So you have got like two masses of same mass. Okay. Then after collision, the first block moves at an angle theta to its initial direction. So it is moving at certain angle and has a speed v by 3. So then the second block speed after the collision is. So what they're asking us to find is what will be the speed of the second block. Got it? So I'll have to figure out this one. This is an elastic collision. Okay. So they've given you clearly this collision is elastic, right? So it should be pretty obvious. As the collision is elastic, we will be able to use energy balance, right? We will be able to balance the initial kinetic energy to that of the final kinetic energy because it is an elastic collision. So in this question, if you end up using like momentum conservation, it will get complicated because they haven't given anything that is related to theta. You got it? So 30 degree, 45 degree, nothing they have given it over here. So in this question, if you have to do the momentum conservation, initial condition is like simple, but after the collision, those two masses were traveling with certain inclination. I do not know much data regarding the inclination, so I'll not be able to put like I cap, j cap component into it, but they have given you clearly it is an elastic collision, which means kinetic energy has to be conserved. Initial kinetic energy has to be same that of the final kinetic energy. So with that notion, I'll be able to do it super easy. Let me do it. So here the initial kinetic energy will be equal to half mv square. Anyway, half will get cancelled out, right? So you will have like initial to be mass, two equal masses, right? Velocity was equal to v square. So that was the initial condition, which should be equal to the final kinetic energy, summation of those two kinetic energies, right? So after the collision, the block moves at an angle theta and has a speed v by 3. Therefore, you will have like m v by 3 the whole square. That was that was one of the first block, right? The second block speed will be, that's what I need to find. So the second block also has the mass same capital M, and then I'll have to get the v dash, right? V dash square in terms of v. So it is pretty obvious. Yeah, only one of the variable is something that I need to get. Mass will get cancelled out, m will get cancelled out. If I just do the rearrangement, I'll get the v dash in terms of v. That's it, simple sum. Just go with energy balance, you'll get the answer straight away. So here you will have v dash square, which will be equal to v square minus v square divided by 9, negative of v square divided by 9. If I do the cross multiplication, you will have 9v square minus v square, that will give you 8v square. That will give you like 8v square divided by 9, isn't it? If I take the root, I'll end up getting the answer. That's it, finished. So V dash will be equal to 2 root 2 V divided by 3. So that will be my answer, which is like option 3. Simple sum. Just do the energy balance, you'll get the answer. The answer is like option 3. Let's move on to the next one. Next question is also simple one. Let me read it. You have got two particles of masses m1, m2 move with initial velocities u1 and then the u2, right? So they have given us the masses and their velocities u1 and u2, right? Then on collision, after collision, one of the particle gets excited to higher level after absorbing energy E, which means there were like kinetic energy into it. When collision did happen, some part of the kinetic energy got absorbed by one of the molecule. Fine, so which means there was a loss in the kinetic energy. So this is obviously not an elastic collision. This is a kind of inelastic collision, right? So some part of the energy got transferred to other form other than the kinetic energy transfer thing. Some part of the energy got transferred to that object in some other form, right? So whatever it is, but one thing is clear, after the collision, some of the kinetic energy has been dissipated to other form, okay? If final velocities of the particles are v1 and v2, then we must have, then how should the relation be related? So how should I actually put this E? Where should I put this E? That's what they're asking over here, fine? So just by the condition they have given, let me frame an equation, then I'll just transfer the E left hand side or right hand side. Accordingly, I'll end up getting the equation, okay? So what was the initial kinetic energy? Initial kinetic energy was equal to half m1 u1 square plus half m2 u2 square, right? So this was the initial kinetic energy of those two masses. After the collision, obviously final kinetic energy should be less because some part of the kinetic energy has been absorbed by that molecule, right? So to other form, some other potential energy got stored into it, right? Whatever it is, it has been dissipated to other form. Therefore, the final kinetic energy that I'm going to write over on the right hand side should be less when compared to the initial kinetic energy, right? Then obviously whatever energy that got decreased will be absorbed in one of that object, right? Okay, yeah, it should be clear. Therefore on the right hand side you will have half m1, okay, v1 square plus half m2 v2 square. So the summation of these two energy has to be less when compared to this term, right? Therefore that decrement in energy will be the energy that got absorbed. So to balance the left hand side and right hand side, I'll have to add that absorbed energy on the right hand side of this particular equation, which will be the epsilon or E. Okay, so this will be the absorbed energy. So half m1 u1 square plus half m2 u2 square. So you have got like half m1 u1 square plus half m2 u2 square negative E. So this E on the right hand side has moved to the left hand side. Therefore negative E, which will give you half m1 v1 square plus half m2 v2 square, right? Therefore the answer here is option 1 straight away, right? You shouldn't have any doubt on the sum. It's an easy one. Let's move on to the next one. Next question is, two spheres A and B of masses m1 and m2 respectively collide. So you're having like two different masses, they're going to collide with each other. A is at rest initially and B is moving with velocity v along the x-axis, okay? So you have got mass A to be at rest and B is going to hit the mass A along the x-axis. After the collision, B has a velocity v by 2. So the velocity of B is going to decrease to a velocity of v by 2 in a direction perpendicular to the original direction, which means initially the B was moving along the x-axis, right? So it will, after the collision, it will have a velocity of v by 2 that will either be along the plus y-axis or along the negative y-axis, right? They have just given you perpendicular to the original direction. That's it. They haven't given anything related to positive or negative axis. It is just perpendicular, okay? The mass A moves after the collision in the direction. So what I need to find is in which direction the mass A is going to move. That's what I need to find. So I'll have to get the theta, whether it is like same as that of B or opposite to the direction of B, whatever it is, I'll have to get the angle. That's what they're asking us to find over here. So in this question, it is pretty obvious. They haven't given anything related to elastic or inelastic, something of that sort. So obviously it has to be inelastic. Anyway, the point is I'll do the momentum conservation first. Then let me try to figure out in which direction the mass A is going to move, okay? Right, so let me do the solving. Let me first put the initial condition over here. Initially, you have got like two different masses. So mass A was at rest, right? Yeah, the mass A, which had a mass of m1, was at rest. And then you have got mass B, which is moving with velocity v along the x-axis, right? So they haven't given anything. It is like plus x or negative x. They haven't given anything related to the direction, but they've given one thing clearly, just it is along the x-axis, right? So here you've got like mass b m2, which is going to move along the x-axis. Let me take it in the positive direction. So this one is going to move in the positive x-axis, okay? So within velocity v. Fine. So this is the initial condition. So after the collision, the mass b will move. Mass b, which has like m2 mass in it, is going to move perpendicular to it. So in this case, I'll just take it in positive y direction itself. I could also take it in the negative y direction, whatever the case it is. It is going to move perpendicular to the original direction. So what will be the, so what I'm supposed to find is what will be the velocity of the mass a. So in which direction the mass a is going to move after the collision. So in which direction this mass should actually move. That's what I need to find it. So here the direction of v2 is something that I need to get. Okay. So in this case, this is like a. So the, let me consider it to be like v1. Okay. So v1 is something that I need to get it over here, right? So this is the setup based on the question. So now let me do the momentum conservation. So the momentum conservation will be like the initial momentum, that should be m2 in this direction, and then velocity v that was along the positive I cap, right? So in this condition you will have like j component into it, because it is pretty obvious this mass b is going to travel in the j component, right? So let me plug in all those directions properly along the vector using the unit vectors. So m2v, this is not an unit one directional motion, okay? So m2v, and then you will have like I cap. You do not want to worry about the m1a, because m1 and its velocity, because it was at rest. So it should be equal to m2, okay? So the velocity of this one was actually equal to v by 2, right? So it was like half of the velocity with which it was actually moving. Therefore, it should be like m2 v by 2, and then the direction was equal to j cap. Got it? What I need to find over here is the velocity of the first mass, final velocity of the first mass, that will be equal to m1, and the velocity was actually equal to vector v1, right? So I'll have to get this vector v1. With that, I'll be able to get the theta over there, right? So let me rearrange it. I'll get the answer. So if I do the rearrangement, you will have, yeah, you will have vector v1, which will be equal to, okay, m1 vector v1, which will be equal to m2 v I cap plus m2 v by 2 j cap, isn't it? Right? Let me factor out the m2. So you'll have vector v1, which will be equal to vector v1, which has to be equal to m2 divided by m1, right? And then you will have yeah, v I cap plus v by 2 j cap, right? I'll be able to factor out v also from this term, but anyway, here v I cap plus v by 2 j cap. So this will give me the required direction. Oh no, I haven't plugged in the negative sign properly, isn't it? So here it should actually be negative, right? This has moved to the negative, therefore it should be like negative, and here also you should get the negative sign over there, and this one also has to be negative, right? So now I have got a vector representation over here. So with this I'll be able to get the direction, isn't it? Yeah, let me do it. So you're just going to have a graph over there. Got it? What they've given is, they are asking us to find the theta with which it's going to move, right? After the collision, this will be the velocity for the situation that I've taken over there. This will be the final velocity, right? Now I know the vectors. So from vectors, I'll be able to get the direction, isn't it? So if I just look at it, it is pretty clear. If one component is moved along the x, then half the component will be moved along the y. So that's how it is related. Is okay. So m2 by m1v is just the constant for I component and then the j component. Only thing that's going to change is one will be like I cap and the other one will be like j cap divided by 2. So whatever factor that you get out of m2, m1 and then the v, you'll have to multiply that one with, you will have to take it as such for I cap, same way you'll have to divide it for the j cap, right? So if that was the case, So you'll get vector something like this. So that will be obviously plus I cap and then the negative j cap if there is a moment of 1 unit along the x-axis. If there is a moment of 1 unit along the x-axis, you will have like half the moment along the negative half moment along the j cap, right? So now I have got the relation between the I and then the j, right? So now I know, now I'll be able to get this theta. So what they're asking us to find is actually the theta, right? So it is pretty obvious. Same as that of B will not be the answer. Opposite to that of B will not be the answer. Either it should be like tan inverse of plus half or negative half, right? So if I just look it over there, so it should be like opposite divided by hypotenuse. That should give me the theta over there. So theta tangent theta will be equal to opposite divided by hypotenuse. So opposite in this situation is like negative half divided by 1. So theta will be equal to tan inverse of negative 1 by 2. For the situation that I've considered, theta should be equal to negative of tan inverse negative 1 by 2, right? So theta should be equal to tan inverse of negative 1 by 2 to the x-axis. So that should be the theta that I need to get it over here, right? Got it? So option 4 should be my answer. So now I have got the theta over here. Now let me take the other one consideration into it, which is like instead of plus direction, right? So in this condition I have taken, this is going to move along the plus j cap. Got it? It could also have moved along the negative j cap because they have just given us like the perpendicular direction. They didn't even mention like plus x-axis or negative x-axis. Same way they have just given us the perpendicular direction. So it could also be the negative j cap. That too is possible, right? If it was in this direction, which means along the negative j cap, then what will I get over here is something like this, m2 v by 2 minus j cap, right? So this term will be like negative. Same way, if I do flip this one, I'll get this term to be positive. Here it will be positive. Therefore, I will end up getting the positive answer, right? So positive answer is also possible in this situation. If I end up getting positive answer, the same way you'll have like if one component is moved along the x, same way half the component will be moved along the y. So still you'll get like 1 by 2 divided by 1, but the sign will get flipped. Instead of negative 1 by 2, I'll have like plus 1 by 2. Same way inside this parameter you will have like plus 1 by 2. So both those answer is also possible. Either I could get like theta equals tan inverse of negative 1 by 2 to the x-axis. That too is possible. Same way, if I've just taken minus j cap, I'll still get the option 3 to be my answer, right? So both those answer is also correct in the situation. Even if I get like option 3, that too is correct. Option 4 is also correct, right? So whenever you get such a question, you will get a dilemma which one to mark, right? So because both the answers are right, obviously first one and then the second option is wrong. So we'll not go into that one. So when you get such a kind of question where you have got like two options to be correct, you will have to mark one of that options, right? You shouldn't mark like two options in the OMR sheet because that's not allowed. So whatever option is correct. So if two answer is correct, just mark one of the answers from it. They'll give you like 4 marks. Got it? If you just end up marking two both those answers, then they'll give you negative one as usual because they'll consider that answer to be wrong, right? So you shouldn't mark two option for the same question. That's not allowed. If two answer is correct, just mark one of the option which is correct. They will reward you with 4 marks, right? If you end up marking the other two options which wasn't correct, okay, so these two options are pretty clear, these two options are wrong. If you just ended up marking this one of these two options, then they will give you like negative 1 mark, okay? So that's how they will evaluate in the NEET examination. Rarely you'll get such a kind of question. So most often you won't encounter such a kind of question in physics or chemistry. So these kind of question you will see in like biology, right? So in biology, those are like statement based question, right? So there is a possibility that two options are right in some situation. Rarely these kind of questions you will end up encountering. So if you encounter such a kind of question, what you have to do is you will have to mark just one of the option which is correct. That's it. They'll give you like 4 marks, right? So you should be clear with this question. So in this question, just do the momentum conservation. You'll end up getting the theta, required theta, right? You shouldn't have any doubt. Let's move on to the next one. Next question is, they've given us a mass m moving horizontally along the x-axis with velocity v, collides and sticks to a mass of 3m moving vertically upwards. Fine. So one of the mass is actually moving horizontally along the plus x-axis. Okay, so this is going to stick to another mass of 3m which was moving upwards along the y-axis with velocity 2v. what they're asking us to find is the final velocity of the combination is, right? So obviously I'll have to do the momentum conservation. You'll get the answer straight away. Only thing is you'll have to plug in I cap and j cap while doing the momentum conservation, right? So let me do the momentum conservation. So here you will have initial momentum, which will be like m, right? This was moving along the plus x-axis with a velocity v, so mv, that will be like I cap. Okay, and then you have got the second mass which was moving vertically upwards, so you will have like 3m that was moving vertically upwards with a velocity 2v, right? So that should be like 2v j cap. So these two mass got stuck to each other and it started moving with same velocity, right? So the final momentum will be equal to, this should be equal to the summation of those two masses, because it got stuck to each other, which will be like 4m. What I need to find over here is the final velocity, which will be like vector v dash, right? Just do the cancelling, you'll get the answer. So if you do the cancelling, you'll have like mass m will get cancelled out. Just do the rearrangement, you'll get the answer. So v dash will be equal to 4v dash, right? So v dash will be equal to v by 4 I cap plus you will have 3 by 2 v j cap. Yes. So the answer over here is 1 by 4, and then option 2 will be my answer, which is like, yeah, 1 by 4 vi cap and then plus 3 by 2 vj cap. Option 2 is my answer, right? Simple sum. Let's move on to the next one. Next question is also simpler one. Let me solve it. Here you have got a ball moving with velocity 2 meter per second collides head on with another stationary ball of double the mass. Fine. So you're having a ball which is moving with a velocity of 2 meter per second. That's going to hit another stationary ball. So the next one had a velocity to be 0 and it was like double the mass. If the coefficient of restitution is 0.5, then their velocities after the collision is, right? So first do the momentum conservation. You'll have like two unknown parameters. Just use the coefficient of restitution formula, substitute 0.5. You'll be able to move away with one of the variables. So the next one, so the unknown variable will be my answer, right? So then their velocities after the collision is, right? Let me do it, you'll get the answer. So initially, let me do the momentum conservation. So initially the mass m had an velocity like 2 meter per second and the second mass was at rest. Therefore initial momentum is done, which should be equal to the final momentum. So the final momentum will be like m. Final velocity of the first mass is like v1. Same way you'll have like plus 2m, right? So then second mass is double the times, therefore you'll have like 2m and its velocity is v2. Fine. So obviously here all the m will get cancelled out, m will get cancelled out. Here in this equation you have got like two variables. So if I have to solve this equation, I'll have to plug one of the variables. Let me take the v2 and then I'll have to change it in terms of v1. Then I'll be able to solve this one and I'll get the v1, right? So if I get the v1, same way, if I just substitute the same v1 into this equation, I'll get the v2, right? So if I have to change v2 in terms of v1, I'll have to use this coefficient of restitution formula, right? So coefficient of restitution is like 0.5, which will be equal to v2 minus v1 divided by u1 minus u2. Got it? So I know u2 should be 0, therefore this one goes to 0 because the initial velocity of the second mass is 0, right? So that one is done. Yeah, just do the rearrangement, I'll get the v2, right? So v2 will be equal to, therefore v2 will be equal to 0.5 u1 plus v1, right? 0.5 u1 plus v1. Now I'm just ready to substitute this v2 in this equation. So if I do substitute that one, I'll get the v1, isn't it? Yeah. What was the u1? u1 was equal to 2 meter per second. So v1 is something that they've given in the question, so I'll be able to substitute 2 in the place of v1, right? So if I do the solving, you will have 2 v1 plus 2 times v2, this entire term, isn't it? 0.5 u1 plus v1. Got it? So let me do the solving. You'll have like 2 which will be equal to v1 plus 2 into 0.5 into 2, right? So 2 into 0.5 into 2, in the place of v1 let me substitute the 2. So half into 2 will give you 1. Therefore here you will have 1 plus v1. Yes, right. So just do the solving, you'll get the answer. So you'll have like 2, that will be equal to v1 plus 2 plus 2 v1, right? Yes, so these two stuff will get cancelled out. Therefore v1 should be equal to 0. Yeah, plus 2 minus 2, that goes to, if one of the two from the right hand side goes to the left hand side, 2 minus 2, that will give you like 0, which will be equal to 3v1. Therefore v1 should be equal to 0. Now I have found out the v1. Yeah, so v1 over here is actually 0. Now I have got the v1. Only stuff that is left is v2, isn't it? So to get the v2, 2, which will be equal to v1, that will give you 0 plus 2 v2, isn't it? Therefore 2 will get cancelled out. v2 should be equal to 1 meter per second. Okay, now I have got the velocity v2. The answer is like 0 comma 1, which is like option 1. Yeah, the answer is like option 1, 0 comma 1, right? The sum should be clear. So to solve the sum, first do the momentum conservation. While doing momentum conservation, you'll have like two unknown variables into it, right? So just to get away one of the variable, use the formula of coefficient of substitution. When you just do it, you will end up getting v2 in terms of v1 or v1 in terms of v2, whatever it is. Just take that v2 or v1 and then substitute in the above momentum conservation equation. You'll end up getting one of the velocities, right? So once you get one of the velocities, just substitute that velocity into the above equation, you'll end up getting the other velocity. By the way, now you have got like two velocities, right? You should be clear. There shouldn't be any doubt on this question. Let's move to the next one. Next question is, a particle is released from height s from the surface of the earth. So you're going to drop a particle from the surface of the earth, right? So that is at a distance of s from the surface of the earth, okay? At a certain height, its kinetic energy is 3 times its potential energy. So when it has reached certain height from the surface of the earth, the hint over here is kinetic energy should be equal to 3 times of its potential energy at that particular instant. Okay, so that's what they have given. That's the second statement. Then what they're asking us to find is the height from the surface of the earth and the speed of the particle at that instant are respectively. So with respect to the earth, what should be the height? That's the first thing that they're asking us to find. Same way they're asking us to find the speed of the particle also, right? So to get this one, the relation is based on this equation, which is kinetic energy has to be equal to 3 times that of the potential energy, right? So here let me draw it such that from the surface of the earth, it should be at a height of, so it should be at certain height h, okay? So this is the height h that I need to find out. So when it has reached this point, when this mass has reached this particular point, you will have kinetic energy that should be equal to 3 times its potential energy, right? So K should be equal to 3 times the potential energy. So that's how it has to be, which means 3 times mgh should give you the kinetic energy of the particle at that instant, okay? So that's how it has to get related. So if that was the case, what should be the height h? That is something that I need to find. I dropped this mass at a distance of s from the surface of the earth, okay? So from the surface of the earth, I just dropped it at a distance of s, okay? In this situation, the initial velocity will be like 0. So at the point of dropping, the initial velocity was equal to 0, okay? U was equal to 0. So if that's going to be the case, it is pretty obvious. First, I'll have to use the kinematic equation, yeah, to get some known result out of it. So from that, I'll be able to equate these two stuff. Kinetic energy K should be equal to 3 times the potential energy at that particular instant, okay? So here, when it is about to reach this position, if I am going to substitute the third kinematic equation, because obviously I do not know time in this situation. So if I use the third kinematic equation, it will be like the velocity v square minus u square. Initial velocity is 0. Therefore, that should be equal to 2gh, isn't it? G is like g. What will be the h? Height in the situation is it has reached s minus h, isn't it? So this distance is something that I have to plug for the h. So that will be like S minus H will give you this displacement, downward displacement, that is going to be negative direction. Anyway, I do not want to put the negative direction here, because if I plug in negative over here for G, I'll have to substitute negative G, so those two negative will become positive, right? By this time you should know this understanding behind it. So now I just know V square, that should be equal to 2G S minus H, right? So here I'll have to get this H. If I need to get the H, I'll have to replace this V in terms of some other component. So that is when I'll be able to get this H in terms of S. So when you look at the option, it is pretty obvious. S is there in the option, right? So I'll have to replace this V. So to replace this V, they have given one more hint to it, which is like kinetic energy at that point will be equal to 3 times the potential energy that got stored into that object. Okay, so this should be equal to half mv square, that was the velocity at that particular instant. So the velocity at that instant is the final velocity with compared to the kinematic equation that I've applied in the upper segment. Okay, so here half mv square will be equal to 3 times the potential energy at that instant, which will give you 3 mgh, isn't it? Okay, so here m will get cancelled out, and then v square should be equal to, so v square will be equal to 6 GH. Got it? Yes, V square will be equal to 6GH. Now I'm ready to substitute this V square into the above equations that I've already found. So if I do substitute that one, you will have 6GH, that will be equal to 2GS. Yeah, 2GS minus 2GH. Okay, so just cancel out all those S in it, G in it. So if I cancel out this G will get cancelled out. If I rearrange this equation, I'll get H in terms of S, isn't it? So if I do the rearrangement, so this thing will get added. So I'll have like 8H, which will be equal to 2S, right? Therefore, S will be equal to, so H, right? So H will be equal to S divided by 4. Fine. So now I have found out the H that is needed over here. So H will be equal to S by 4. So when you look at the option, the first one is also correct, the second one, third one. So like 3 option is right over there. So next what I need to find is the speed of the particle at that instant, right? So to get the speed of the particle at this instant, now I have found out the H, isn't it? So if I just substitute S by 4 in the situation, in this case, in this equation, I'll get the V square, velocity at that instant, right? So that will be equal to V square, which should be equal to 2G S minus S by 4, right? So that will give you 3S divided by 4, 3S divided by 4, right? So just cancel out and take square root, you'll get the answer. So if you do cancel out this one, you'll have like 2 in the denominator, that will give you 3GS divided by 2, right? So root of 3GS by 2 will be my answer. Fine, so root of 3GS by 2, that is like option 1 in this case. So the answer for this question is option 1. You should be clear with this sum, you shouldn't have any doubt in it. So in this sum, I'm just going to drop an object, the initial just dropping it, therefore initial velocity was 0. There came an instant where the kinetic energy of that object was equal to 3 times its potential energy, right? So K was equal to 3 times U. So I was able to relate between half mv square, which will be equal to the 3 times mgh, right? So I was able to equate those two stuff. So with that, I just found a relation between the v square and then the h over there. So to replace that v in terms of s, what I did is I just used the kinematic equation in the first part. Okay, so in the first part, when I equated with third kinematic equation, I was able to get the relation between the v square and then the s. When I got that relation, I was able to find out the h, right? So when I got the h, just use the same h into the kinematic equation, you'll end up getting the velocity at that particular instant, right? So you should be clear with this sum, you shouldn't have any doubt. Let's move on to the next one. Next question is simple one, let me read it. Here you have got the energy that will be ideally radiated by a 100 kilowatt transmitted in 1 RS. Fine. So this is an ideal situation, which means there wouldn't be any energy loss in it. Whatever energy that I gave into it, it got transmitted in the form of radiation. Fine. There wasn't any loss into it. If that was the case, then what will be the energy that got radiated, right? So to get the energy, they have given you the power, which is like kilowatt, right? So power was equal to 100 kilowatt. What they're asking us to find is actually the energy. So just multiply with time, you'll get the energy. Fine. So simple. So energy will be equal to power into time, which is like 100 into 10 power 3 into the time. Time will be 60 into 60 because they have given you like 1 hour. I'll have to change it to seconds, right? So here you will have 36 into, let me just count the zeros. So here you have got like 2 and then 3, which will give you like 5 and then 6, 7. So 36 into 10 power 7 will be my answer, 10 power 7 joule, right? Let me look into the option. You have got 36 into 10 power 7, which will be like option 2, right? You should be clear with the sum. You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is also a simple one. Let me solve it. An electric lift with a maximum load of 2000 kg. Lift plus passenger, which means they have given you the total mass, is moving up with a constant velocity 1.5 meter per second, right? So they have given you the mass and it is moving up. So the motor is actually pulling it upwards with the speed of 1.5 meter per second, right? The frictional force opposing the motion is 3000 Newton, which means I just need to give extra 3000 Newton other than this balancing the mass stuff, okay? Because the frictional force is acting between the pulley and then the rope. I'll have to overcome that force also so that the motor is able to pull the lift upwards, right? The minimum power delivered by the motor to the lift is. So what should be the power that has to be generated in the motor so that it is able to lift the lift, okay? That lift entire load. Got it? Let me draw the diagram, you'll get it. So here you have got a lift which needs to move upwards, right? And then there is a friction that is acting between this pulley and then the rope. So it has to provide extra energy for this repulsive force between the pulley and then the frictional force between the pulley and then the rope, right? So altogether you have got like 2000 kg, right? Which means 20,000 Newton, right? So you have got like 20,000 Newton of lift mass that is acting downwards. Therefore, you need to give a force of 20,000 Newton upwards, right? Just to lift this one up. But there is a resistive force that is acting between the pulley and then the rope, which is equal to 3000 extra 3000 Newton. Okay, so together I'll have to balance this 20,000 Newton force. Same way, I'll have to overcome that frictional force between the pulley and then the rope. Okay, so that will be like 3000 Newton. So altogether, I'll have to give like 23,000 Newton to pull this mass upward with a constant velocity of 1.5 meter per second, right? So in order to pull this one upwards, I'll have to give, the motor has to give a force of 23,000 Newton, right? If I give like 23,000 Newton, then obviously the force given by the motor has actually balanced this 20,000. I mean, has balanced this 20,000 along with this 3,000 Newton. Okay, so you are going to have a frictional force that will be equal to 3,000. Okay, so now the force that I gave actually balanced the entire setup. Therefore, if I just give a small push to it, it will be able to move upward with the constant velocity, right? Once it is balanced. Now, if I just give a small push to it, it will be moving upwards, right? Because the force got balanced, right? So 23,000 Newton force is the force that is required to pull this lift upwards with a constant velocity. That velocity was equal to 1.5 meter per second, right? So now I just found out what was the force that is needed to be given by that motor to the pulley is found out, right? To the lift is actually found out. Therefore, to get the power, what I need to do, I know the force, I know the velocity. If I have to get the power, power will be equal to force times the velocity, isn't it? Simple straight away logic, right? So here power will be equal to force times the velocity. Only part where you'll get confused is you will have to add this 3000 also, right? It's not the 20,000 that I'm balancing. I'm also balancing the effect of frictional force that sums up to 3000 Newton. I'll have to balance that one also. So altogether it is like 23,000. So the power that needs to be generated by the motor will be equal to 23,000 into the velocity, which will be equal to 1.5. Okay, so 23,000 into 1.5 will give you the answer. So that will be equal to, yeah, 23 into 15. Okay, so that will give you 5 3 15 1 4 0 1, so that will be like 3. Okay, so you'll have 5 4 3 4 5, so 34.5 into 1000, right? So 34.5 into 1000 will give you 34500 watt. Okay, so 34500 watt will be my answer, which is like option 4 for this question, right? You should be clear with this sum, you shouldn't have any doubt, right? So in this sum, I just need to find the force that is required to be produced by that motor. So to get that force, I shouldn't only consider the lift of the mass of the lift or the force that is needed to balance the lift. I'll have to also add the frictional force that I need to overcome, which is acting between the pulley and then the rope, right? You should be clear with this sum, you shouldn't have any doubt. Let's move on to the next one. This sum is also a simple one. They have given you the potential energy of a long spring when stretched by 2 centimeter is U, right? So they have given you the first condition. What they're asking us to find is if the spring is stretched by 8 centimeter, the potential energy stored in it will be, right? Simple, straightforward sum. So U should be equal to half kx square, isn't it? So in the initial condition, the potential energy U got stored into the spring when I stretched it by 2 centimeter, which will be equal to half k 2 square, right? Now what they're asking us to find is what will be the potential energy stored into it if I have stretched it to a distance of 8 centimeters. So that will be like half k 8 square, right? So just do this all along, you'll get the answer. Half will get cancelled out, k will get cancelled out, 1 by 4, that all will get cancelled out, right? So u dash will be equal to u divided by no u into 16. So 16u will be my answer, which is like option 4, right? Simple sum. You shouldn't have any doubt. Let's move to the next one. Next question is conceptual based question. Let me read it. A bullet from a gun is fired on a rectangular wooden block with velocity u, right? So you're just going to fire a bullet against a wooden block with an initial velocity u. When a bullet travels 24 centimeters through the block along its length horizontally, which means when the bullet has traveled like 24 centimeter inside penetrating the wooden block, velocity becomes u by 3. The velocity has decreased to u by 3, right? Then they have given you, then it's further penetrates into the block in the same direction before coming to rest exactly at the other end of the block, which means it has just came out of the wooden block and the velocity became 0, right? Fine. So when it has covered like 24 centimeter, the velocity became u by 3. When it was about to come out of that wooden block, the velocity became 0, which means it has completely pierced through the wooden block, but it didn't have any velocity after piercing it. It has lost all its kinetic energy, right? So then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block, right? What they're asking us to find is the total length of the block. Is to get the total length of the block, first I'll have to generate the equation from the data that they've given, right? So here when it has pierced like 24 centimeter, it has lost some part of energy, right? So to get that relation, so obviously initially the total kinetic energy was equal to half m u square, right? The final energy after it has pierced through 24 centimeter was equal to negative of half m u by 3 the whole square, right? So this was the initial energy after piercing 24 centimeter. This was the final energy. So if I do subtract these two energies, I know obviously that was the amount of energy that was used to pierce the wooden block. Okay, so there was a resistive force given by the wooden block which was consuming that energy, so it was breaking that wooden block, right? So the resistive force given by the wooden block is like F, and then it has traveled a distance of 24 centimeter, isn't it? One part of the equation is done, right? So this much amount of energy got consumed when it was about to move 24 centimeter against the wooden block, right? If all the energy got consumed, then it would have moved the extra length. So that will be the total length of the block, right? So if all the energy got consumed, I'm just going to take the ratio. So if all the energy got consumed, which will be like half m u square. If all the energy got consumed, the resistive force given by the wooden block will be the same. That will be like F. It will be able to cover that much amount of length, right? So the total length of the block, it will be able to cover that distance, because when the bullet has reached the other end of the block, it got the velocity to be 0, which means it completely came to rest, right? It has lost all its energy. Fine. You should be clear with the ratios that I have taken over here. So that will be the distance x, right? So this ratio should be clear. It's like half mu square minus half mu by 3 the whole square gave you the amount of energy that got lost to the wooden block. Okay, so this was the energy that got lost, and which should be equal to the resistive force given by the wooden block times the displacement, right? So if all the energy got lost, I'll be able to cover the entire length of the block, isn't it? So just find the x, you'll get the answer. That's it, finished. Simple sums, right? So here you will have like f that will get cancelled out. Same way, if I do factor out half mv square, if I do factor out half mv square, that too will get cancelled out. Half mu square, inside you'll have like 1 minus 1 divided by 9 divided by half mu square, which will be equal to 24 into 10 power minus 2 divided by x. Okay, so here half mv square will get cancelled out, and then if I do the cross multiplication, you have x, which will be equal to, this is actually 9 minus 8, I mean 9 minus 1 divided by 9, that will give you like 8 by 9, right? So on the left hand side, you will have like 8 by 9, 24 into 10 power minus 2. Okay, do not worry about the 10 power minus 2, that's going to be centimeter anyways. So x will be equal to 24 into 9 divided by 8 centimeter, right? Just do the solving, you'll get the answer. So if I do cancel out this one, you will have like these two stuff cancelled out, and this will be like 3. So 9 into 3, that's going to be like 27 centimeter, right? So the answer for this question is like 27 centimeter, which is like option 1, right? You should be clear with this question, right? You shouldn't have any doubt on the sum. So just take the difference, you'll get the energy loss in the first. What was the energy loss? That will be equal to the distance traveled and the resistive force given by the wooden block. Just take the ratios for two different circumstances. You'll end up getting the total length of the block, right? It should be clear. Let's move on to the next one. Now we are into the last question of this session, right? As I've already told you, this question will be based on the dimension analysis. Let me do it. It will be easy. Here you have got, if force F, velocity v, and time t are taken as fundamental units, then the dimensions of the mass are. So I'll have to get the dimension for the mass, right? So on the left hand side, you should have only mass. On the right hand side, you'll have to make a combination of force, velocity, and then the time to get the mass, right? So in what fashion I should actually multiply this force, velocity, and time to get the dimension of mass? That's what I need to get over here. So if I need to frame the equation, it will be such that you will only have mass on the left hand side. So you will have like mass power 1, and then you'll have L power 0, T power 0, isn't it? This has to be equal to these three parameters on the right hand side, right? So this unit has to match with force power A, okay, and then velocity power B, and then time T power C. So I'll have to get combination of these three stuff in certain fashion, so that this one and the left hand side has to match with each other, right? So what will be the dimension for the force? So dimension for the force will be like mass times the acceleration. So for the mass, it will be like m, right? So for the mass, it will be like m. To get the acceleration, that will be like L t power minus 2, right? Meter per second square. So it will be like L t power minus 2 the whole power a. So this is the same thing that we have already discussed in the units and measurements chapter. You should be clear with what I'm doing here. I'm just making here the left hand side and the right hand side to have the same units into it, right? Fine, you should be clear. So here I've got like ml t power minus 2. For the force, I've substituted the dimension. I just have to figure out the power over here, right? For the velocity, you will have L t power minus 1, power is like b, and then t power c, right? Yeah, for the time, you'll have like c. Now my left hand side is done, isn't it? Right hand side is done. Just do the inner multiplication and then figure out m, l, t. Okay, so here you'll have like m, and then you'll have power a. You do not have any m in the other term, therefore you'll just have m power a. And then if you look at the l, you have like l power a, L power b, right? So it will be like L power a plus b. So the powers will get added, a plus b. And then for the time, you'll have like negative 2a. So for the time t, you will have minus 2a negative b plus c, isn't it? Fine. Now I'm just done with the power. So I'll have to equate this one to m power 1, L power 0, and then t power 0, right? So if I just equate this one, I'll get how it should actually get related. So if I get like a, for a, if I get like 1, so f power 1 will be the right combination. Okay, so I just need to find the a, b, and c. I'll end up getting the answer. Okay, so over here, let me equate the m. So a will be equal to 1, that's straight away matched. A plus b will be equal to 0, right? And then you have got like minus 2a minus 2 minus b plus c, that too will be equal to 0, right? So if I do substitute a as 1 in this case, then you will have like b, a as 1, so b will be like negative 1. Yeah, so for the next one, it will be like minus 2 into 1, and then negative minus minus 1, that will be like plus 1, plus c, that will go to 0. So here in this one, you will have like minus 2 plus 1, that will give you negative 1 plus c, that will be equal to 0. Therefore, c will be equal to 1, right? Now I have found the constant a, b, and c, which will be in the power of force, velocity, and then the time, okay? So a should be equal to 1, b should be equal to negative 1, c will be equal to plus 1. This is how it has to get related. So left hand side unit and the right hand side unit will be balanced to the mass, okay? So it should be f power 1. So f power 1, and then you have got like v power minus 1, okay, and then the t power 1. F power 1, v power minus 1, and then the t power 1. So that will be like option 4, right? You should be clear with this question, right? So just the dimension analysis one, I've put it in this chapter because in this chapter we have learned what is meant by force. F was equal to ma. From that, I was able to get the dimension. So it's just simple, straight away. Just do the balancing of left hand side and then the right hand side, you'll get the answer, right? So by now we should be clear with all the sums that we have discussed, right? In all those 5 to 6 sessions we have done, we did see sums that are related to the spring and then the collision and then the basic understanding behind the work. We did see the sums based on the vectors and all those stuff, right? So this is one of the easiest chapters in the physics, right? So you should be clear with all the concepts that we have learned. Same way, simple, straight away. Just you are thorough with the formula and basic understanding, you will be able to get the answer, right? So this will be the last session for this chapter, work, energy, and power. You have to be clear with all the concepts and the sums that I have taught you, right? With this, the video gets completed. Bye.